Nearly half the internet runs on WordPress, and right now every one of those sites is broadcasting exactly where its weak spots are. The owners never notice it, and attackers never miss it. Today we're building a WordPress lab from scratch, planting a real vulnerability inside it, then hunting it down exactly the way an attacker would. Everything you see here runs against a site I own. Scanning any site you don't have written permission to test is illegal, so keep all of this inside your own lab. Stay with me, and we'll build the whole thing together, step by step. First thing we always do is update the system. Run sudo apt update to refresh our package lists, then sudo apt upgrade-y to install anything pending. Mine's already up to date, so this finishes right away. Now before we install anything, let me tell you what this video is really about. WordPress powers a massive share of everything you see on the web, and behind almost every WordPress site is a collection of plugins. Plugins are where vulnerabilities live. An outdated plugin is a known weakness, sitting on a public server, just waiting. The problem is that finding those plugins by hand is slow. You'd have to know exactly what to look for, and you'd have to do it one site at a time. WPProbe solves that. It reads the data the site is already broadcasting and matches every plugin it finds against a database of known vulnerabilities. The whole thing takes seconds. WPProbe now ships as a default tool in Kali Linux 2026. If you're on a recent Kali, it's already there. Install it with sudo apt install -y WPProbe, and this confirms the version and wires everything up. Now WPProbe reads its vulnerability database from a specific folder in your home directory. Let's create that folder with makedir and move into it with cd, pointing both at the WPProbe config directory, so the next command saves the file exactly where the tool expects it. Next, we pull the database itself. WPProbe has a built-in updater for this, but we'll fetch it directly with wget, followed by the database URL, which is the more reliable method. This file holds over 40,000 known CVEs for WordPress plugins, sorted by severity. Once it finishes, head back to your home directory with cd, then run WPProbe list to confirm the database loaded. Look at that. Over 2,000 critical CVEs alone, all indexed and ready to query. The tool is armed. To demonstrate this properly, we need a real WordPress site that we own. We're going to spin one up locally, using Docker, which lets us build a fully working environment in minutes, and tear it down just as fast. Install it with sudo apt install -y docker.io docker-compose. During the install, it'll pause and ask about configuring docker.io. We don't need to change anything here, so select no and continue. Now start the daemon with sudo systemctl enable docker -- now. This launches Docker right away, and make sure it comes back on every boot. Without this, the next step fails immediately. Now let's define the lab. Open a new file with nano docker-compose.yml. A compose file tells Docker exactly what containers to create and how they talk to each other. This file creates three things: a MySQL database that WordPress stores all its data in, a WordPress container running on port 8090, and a small WP-CLI helper that we use to install WordPress and our target plugin without ever touching a browser. Paste the file in, then save it and exit. Now bring it all up with sudo docker compose up-d. This reads the compose file and starts all three containers in the background. The first time you run this, it pulls the images from Docker Hub, so give it a moment to finish. Before we install WordPress, let's set up a shortcut. Write this alias that maps WP to the full Docker command. Now instead of typing that long command every single time, we just type WP. This only lives for the current terminal session, which is exactly what we want for the demo. Now install WordPress straight from the command line with WP core install, passing the title, admin user, password, and URL. No browser wizard, no clicking through setup screens, done in one line. Here's the deliberate part. Run WP plugin install give, but pin it to version 3.14.1 and activate it in the same command. GiveWP is a real donation plugin with over 100,000 active installs, and this particular version carries CVE 2024-5932, a PHP object injection flaw that leads to remote code execution and scores a perfect 10.0 on the CVSS scale. We're not installing this to exploit it. We're installing it to see exactly what an attacker sees when they scan a site running an outdated version. Confirm it's live with WP plugin list, filtered to active plugins. GiveWP is there, status active. The target is set. Open your browser to localhost on port 8090. This is what anyone on the internet sees when they visit a WordPress site. A homepage, some default content, nothing unusual. No visible sign of what's running underneath. But WordPress has a habit of talking about itself. Add the REST route parameter to that same URL and reload. This is the REST interface. It's public by default and needs no login. Every active plugin that registers a route announces itself right here. Look at this entry. Give-API/v2. That's GiveWP, sitting in plain sight, telling anyone who asks exactly what plugin is running on this site. A human reading this by hand would take hours, and matching every plugin against a vulnerability database manually would be nearly impossible. This is exactly what WPProbe automates. This is it. Run WPProbe scan and point it at our local site with the URL flag. WPProbe reads the REST interface, identifies the plugins, pulls the exact versions, and matches them against the vulnerability database, all in a single pass. Look at the result. GiveWP, sitting right at the top. 6 critical vulnerabilities, every single one of them unauthenticated. That word matters. Unauthenticated means an attacker needs no account, no password, no session, and no interaction from anyone on the site. They reach the URL, and the vulnerability is right there. Look at these. A couple of them are PHP object injection, leading to remote code execution, flagged critical, the most severe rating the scanner assigns. That means an attacker could run their own code on this server, and the scanner surfaced all of it in seconds, from one command. The default mode is stealthy, reading only the REST interface. Run the same scan again, but switch it to hybrid mode. Hybrid adds a brute force pass on top, checking plugin paths directly, which catches plugins that never register a REST route at all. For a thorough audit, you'd run hybrid. For a quiet initial probe, you'd start with stealthy. The database is also fully searchable. Run WPProbe search against the Give plugin, and it pulls every known CVE for GiveWP, including ones that affect newer versions, so you can track a plugin's full history before deciding whether to trust it. Now run the same search, but filter it by critical severity and unauthenticated access only. This is how you triage. These are the vulnerabilities that ask the least of an attacker and deliver the most. If you're working through a site audit, this is where you start. For real work, you save the output. Run the scan again with the output flag pointing to a results file. Use JSON if you're feeding it into another tool or a pipeline, or swap the extension for CSV if you're handing results to a client or opening them in a spreadsheet. Peek at the top of the file with head, and you'll see everything the tree showed you, now with the full CVE links, CVSS vectors, and plugin metadata packed into a structured format any tool can read. Now let's talk about the other side of this. If you own a site, what does all this mean for you? The most important fix is also the simplest. Update the plugin, and a single update wipes out every critical row you just saw. The vulnerability window closes the moment the patch lands, and WPProbe would come back with nothing on an updated site. Next, delete plugins you don't use. An inactive plugin still sitting in the plugins folder is still attack surface. If you're not using it, remove it completely, not just deactivate it. Then, restrict what the REST interface exposes. You can limit which routes are publicly reachable and strip version fingerprints from plugin responses, so a scanner has far less to work with. And put a web application firewall in front of the site. It won't stop a determined attacker forever, but it blocks the brute force pass that hybrid mode relies on and makes enumeration far more expensive. Here's the key insight. WPProbe never broke into anything. It read data the site was already publishing. Defense isn't about hiding from sophisticated attacks. Most of the time, it's about not handing out the information in the first place. That's WPProbe, one of the newest additions to Kali Linux 2026, and one of the most practical tools for WordPress recon in a real pen testing workflow. Tell me in the comments which tool or target you want me to cover next. Until then, this is Tech Sky, your ultimate battleground of cybersecurity and ethical hacking. Stay curious, stay ethical, and keep learning.